Ever turn on your tap and think, where's this actually coming from? And more importantly, is it always going to be there when I need it? Welcome to this explainer. Today, we're asking a pretty crucial question about the security of our most vital resource amid global climate scarcity. We're going to look at exactly how water utilities are required to assess and report their water supply resilience. And look, we aren't just talking about abstract environmental ideas here. We're diving into the hard financial-grade metrics that utilities use to prove to investors and to the public that they are genuinely prepared for a drier future.
Okay, let's jump right into our roadmap for today. We're going to cover 1. The threat of scarcity, 2. Measuring baseline water stress, 3. Reliance on third parties, 4. The recycled water buffer, and finally 5. Strategic risk management. All right, kicking things off with Section 1, the threat of scarcity. So why do we even need these metrics in the first place? Well, the reality is that factors like climate change, increasingly frequent and severe droughts, and just competing users are actively jeopardizing our most basic water supplies. When a utility faces water scarcity, it is not just some distant environmental problem, it is an immediate, severe threat to their financial performance and operational continuity. Because if they can't reliably source water, they literally can't deliver their product. That leads to revenue declines, mandated water restrictions, and just massive infrastructure challenges. To measure this, we look to the SASB framework for water supply resilience metrics. Specifically, we're zeroing in on metrics IFWU 440, A1.1, A1.2, and A1.3. This framework mandates exactly how utilities have to report their exposure to these critical scarcity threats. It brilliantly shifts the entire conversation from vague promises to highly specific, standardized data points that anyone can evaluate.
Moving right along to Section 2, measuring baseline water stress.
So, how do utilities actually figure out their vulnerability? Notice the precision required here. They can't just guess if their region is stressed. They are required to use specific, rigorous tools, like the World Resources Institute's Aqueduct Water Risk Atlas, to classify their regions. Utilities must report the exact amount of fresh water sourced from regions categorized as having high or extremely high baseline water stress. And SASB even defines what fresh water means here. It's water that has less than 1,000 parts per million of dissolved solids. So, a utility has to calculate thousands of cubic meters of water sourced from these highly vulnerable areas. It instantly puts a real number on exactly how much of their core product is sitting right in the crosshairs of climate scarcity.
Which brings us to Section 3, reliance on third parties. This builds right on that stress level by asking a really critical follow-up question. Who actually controls that vulnerable water? This is the second half of Metric 440A.1, and it's a fascinating look at supply chain vulnerability. Utilities have to report the exact percentage of that highly stressed fresh water that is purchased wholesale from a third party. Think about what this actually means. If a utility sources its own water directly from a local, stressed groundwater basin, that's definitely a risk. But if they're buying that water from a neighboring government entity or some private third party in a stressed region, that reveals a totally hidden layer of dependency. It is an external risk that the utility doesn't even directly control. Because if that third party cuts off the supply or drastically skyrockets prices during a drought, well, the utility and you, the customer, are left completely exposed.
Let's pivot a bit and look at solutions in Section 4, the recycled water buffer.
If sourcing fresh water from stressed regions is the big risk, then Metric 448.2 introduces the mitigation. We are talking about recycled water as a crucial way utilities can diversify their water portfolio to buffer against those scarcity risks. Under the standard, utilities must quantitatively report the total volume in cubic meters of recycled water delivered to customers. To be super clear on the definition here, recycled water means wastewater that is intentionally treated to specific quality criteria so that it can actually be reused. Every single cubic meter of recycled water used is a cubic meter of precious, highly stressed fresh water saved. By tracking this number year over year, we can see for sure if a utility is actively building a resilient, circular water economy or if they're simply crossing their fingers and hoping it rains.
And what's actually pretty fascinating here is the sheer variety of approved uses that count as a buffer. Recycled water is not just a one-trick pony. It ranges from potable reuse, which could be indirectly boosting our drinking water supply using an environmental buffer, all the way to non-potable uses. Think watering golf courses, running heavy industrial cooling processes, or irrigating crops. It even covers environmental reuse, like pumping treated water back into the earth to recharge depleted groundwater aquifers or enhance local wetlands. Seeing this variety of approved uses proves that a smart, resilient utility is one that creatively matches the right quality of treated water to the right end use, maximizing efficiency across the board.
Finally, let's zoom out for Section 5, Strategic Risk Management.
Because the numbers alone only tell part of the story, Metric 440.8.3 focuses on the qualitative narrative. How are utilities actually planning for long-term operational continuity in the face of these immense challenges? In their reports, utilities are required to discuss their specific strategic efforts to secure reliable long-term supplies. Are they diversifying their sources between surface water, groundwater, and ocean desalination? What happens if a massive earthquake takes out a critical aqueduct? Do they have a contingency plan? But here's what you should absolutely take away from this. The standard requires them to manage and disclose complex life cycle trade-offs. For example, let's say a utility decides to build a massive new reservoir to store water for dry years. Sounds great for resilience, right? But that facility requires land use, massive amounts of construction energy, and creates ongoing greenhouse gas emissions. The utility must explain why they chose this practice despite those environmental trade-offs. It forces a deeply transparent conversation about the true cost of water security.
So, we're going to wrap up this explainer with a provocative question for you to chew on about your own community. Where does your water come from, and will your local infrastructure be resilient enough for the future? Now that you understand how baseline water stress is measured, the real risks of relying on third-party purchases, and the massive importance of a recycled water buffer, I highly encourage you to apply these very metrics to the utility managing your most vital resource. Seriously, go look up your local water provider. Are they being transparent about their climate risks? Are they actually diversifying their portfolio? Because understanding these metrics is way more than just an accounting exercise. It's about the fundamental resilience of the places we call home. Thanks for joining me on this explainer, and keep asking the right questions.